today we are going to do section 6.5. This is a very important section and it's quite long, so I'm going to divide it into two parts. Each part will have its own homework section, okay? But they are, of course, the same section, so the homework will come from the same place at the end of this section. And I feel that might go a little easier. So please take this, study this section very carefully and do all the homework I assign. It will look like there's a lot of homework, but like most logarithm, the homework is short and sweet most of the time, okay? And however, it can be a bit confusing, and which is why I would like you to do more homework than more than average amount of homework to get a good grasp of the material, because this part is very, very important. Okay, so first let's look at page 607 towards the bottom of the page, where we're going to prove the product rule. That is, the logarithm of something multiplied together is the same as the logarithm of each individual added up. Okay, and so, but first I'm going to demonstrate why this is the case. Now, before that, let's go back to the principle. What does logarithm mean? Logarithm of b of y equal to x means b to the power x equal to y. Okay, right here. These two statements are the same. So whenever you try to figure out log base b of y, what you're asking yourself is b to what power equal to y? Okay, see? B to what power equal to y? So x is what you're looking for. So that is the meaning of logarithm. That's what we've been doing, and bear that in mind. Okay, this entire chapter is based on this principle alone. These two statements says exactly the same thing. Now, having said that, let's look at this. And to prove the sum of the product of log is the same as adding each one together, adding each one individually. We'll do it just like the book shows it. Okay, we have two things in. Let me think about this. All right, so let's do this, but I'm gonna do it slightly differently from the book because I think my way might be a little clearer, but it's up to you, okay? If you prefer the book's notation, that's fine too. And so anyway, so let's say we have, we're calculating the log of m times n. The big M and big N are just two numbers, okay? So let's look at this. So let's say we're calculating log of some base, all right? We'll call the base b, and we're calculating m times n, okay? And that would be equal to now, first, let's assume that we know this, okay? That is log of base b, b to the power b of just m itself, okay? M itself, b. All right, let's call this value equal to c. All right, and then we'll call the other value log base b of the n. We'll call this value equal to d, all right? Okay, so then what this means is that b to the power c, following this principle, right? B to the power c is going to be equal to big M, and b to the power d is going to be equal to n. As a result, then so m is this thing and n is this thing, all right? So we'll write it like this. So this equal to log base b. The first m is b to the power c. And the second one, n, is b to the power d. And now we're going to apply exponential rules. The exponential rules that says that when you have two numbers that are the same, raised to different powers, the result is the same as adding the powers together. So this equal to log log b, and let's see, b to the power c plus d. And what is log b to the b and then b to the power c plus d. That is you're asking yourself the question, b to what power equals to b to the power c plus d? And that would be equal to c plus d, actually. That's c plus d, okay? Because b to the power c plus d is equal to b to the power c plus d, basically. And because following this principle, okay, b to the power x will be equal to y. That is, b to the power of whatever log equals to has to be equal to in here. So the question is, b to what power equal to b to the power c plus d? Well, the answer is c plus d. So that's where this comes from. Now, if that is the case, then the next thing we do is, what is c plus d? C plus d is from this principle we have, c is log base of m, right? So c is log b of m. And then d, similarly, is the other one, log base of b of n. So that is how we prove this thing. That is the product of two numbers, if you take the log, is the same as the product as the sum of individual logs added up. So log of any two numbers, okay, you can break it up into an addition, which is, and all that because of this relationship. You're basically repeating this relationship in this term. The same way that these two are the same statement, this and this, basically you're saying the same thing, is that exponents can be added up. Okay, so but finally what we're doing here is here's the principle. That is, which I'll write it down right here. That is log of any two numbers, log AB, okay, is equal to log A plus log B. Log A plus log B. Of any two numbers, okay, regardless of what the base, this rule applies. So that is as we have proved here. So please remember this. This principle is very important. Okay, so write this down in your cheat sheet, and we're going to be using it a lot. So that is the first principle right here. Right. Okay. So then next, let's do something with it. Example 1. All right. Example 1 says we on the following page, page 608. Now let's look at example 1 on page 608, where we have the log base 3 of the stuff here, and we're supposed to expand it. Okay, fine. Let's expand this thing. Okay. Now to expand this thing, then we apply this principle. That is the log of any numbers multiplied together. You can break it up into addition of the chunks. So let's do that, okay? And so we have various things being multiplied together, and we'll do it exactly like it says here. So this will be equal to log base 3 of 30, okay? Plus log base 3 of x plus log base 3 of 3x plus 4. Now that seems easy enough, right? And so like I say, logarithm is very easy to do, but it can get confusing. Sometimes you're like, when am I adding and when am I subtracting again? So that's why you need to write this formula in the cheat sheet. When log of two things multiplied together can be split up into addition. Okay, that's the principle, and that's what we're doing right here. There's more than two things being multiplied together. There is 1, 2, 3 terms being multiplied together. So we have this. Now this is not the answer in the back of the book, because the book wants you to break this stuff even further. Fine, let's do it. What is 30? 30 is 2 times 15, which is 2 times 3 times 5. So the book wants you to break that up too. So let's break it. Okay, so that equal to log of 2. Okay, 2 plus log of 3, and then log of 5. And then that just goes, that's only 30. Okay, plus that, plus that, plus that, or something. Okay, so that is, as you can see, that is the answer. The answer is very long, but not particularly difficult. You just have to have the patience to write it out. So that is that demonstrates example 1. The next thing we are going to prove is the quotient rule for logarithms. The quotient rule works the same way as the multiplication rule. The multiplication rule says when you think the product rule, which says when you multiply together, the multiplication translates into addition. The quotient rule says division translates into subtraction, which we will do this after I erase the board. So next, let's go to page 608 and we'll prove the quotient rule, which it goes like this. Let's say we need to do log of m over n. Okay, again, log base m, we'll call it c. Okay, and then n, we'll call it d. Now, in that case, what this means, that this part doesn't change, right? Because if log b of m equals to c, that by this definition means b to raised to the power c equals to m, similarly, and then b raised to the power d equals to n. So as a result, this is equal to b to the c. Let's see, this is the same as b to the c, okay, divided by m is b to the c, and then b to the d, and that's the same as c minus d, and this is from chapter 1, exponents. Okay, division translates into subtraction in exponents. Now, knowing that, then the same principle applies. That is, if this is the case, then next thing we're going to calculate is b to what power equals to b to the power c minus d. That would be c minus d. Okay, and by definition of logarithm, b to this power need to be what's in here. And this what's in here is b to the power c minus d, and therefore b to the power c minus d is b to the power c minus d. So that equals to c minus d, and c is log of m, right? And d is log of n, and we'll put a minus sign here, and then the same principle applies. And that's how the quotient rule applies. So then we'll write down the quotient rule here. In general, I had it as a and b before, but we already have b as the base, so I changed it to c and d. I feel that might be better. So the quotient rule states the log of c divided by d, okay, and that would be equal to log of c minus log of d. So division translates into subtraction is what this means. And again, this is very important, and please write this down in your cheat sheet, and you will be referring to it in the future whenever you forgot, was it plus, minus, which way did it go? You can look at the cheat sheet right away. So so with that, let's do example. Where's the next example? Okay, there's some example here. Example 2. Okay, so let me write that down. So this is example 2 on page 609. We have this pile of stuff. By the way, I should have mentioned that the base doesn't make any difference, okay? Because we proved this with just any old base. So I didn't write the base here. It works for all logs. Well, as long as the base is the same, you can't shift base midterm. That wouldn't make any sense. But as long as the base is the same, doesn't matter what base you have written here. So I'm skipping the base writing. And anyway, so now let's do example 2. It's log base 2. And for now, we don't care what base it is, but we'll write it down. So we need to expand this thing with this principle. That is, multiplication translates into addition, and division translates into subtraction. And that's all we have to do. So then let's do that, okay? And this is multiplication. So we have, we'll write it all out. This equal to log base log 2, okay? And first one is 15, okay? Plus, yeah, there's a lot of writing here, but you get the idea, okay? X, and then plus log of x minus 1. That's the addition. This is the multiplication part. So we'll translate it into addition by this by the product rule of log. And this ain't all, okay? Next, we're gonna do division. These things are all in the denominator, so they're all being subtracted. So we're gonna write a giant parentheses, and which will include all the stuff, okay? And so starting without parentheses, then log 2, this thing, write all this down, minus log, okay, continue without writing log 2, 3x, and yeah. All right, 3x together is inside log 2. And then, sorry, 3x plus 4. Why didn't I see that? 3x plus 4. Plus 4. Where's plus 4? Right? 3x plus 4. Okay, and then this is a plus in here. It's actually division, but we're dividing by everything's down here, and everything down here this is being multiplied, okay? And the subtraction sign, which is division, will apply to each one when we take the parentheses out. So right now, we'll continue the plus, and log 2. Patiently write all the stuff, 2 minus x, and then the close parentheses, okay? This one and this one is connected, and the whole thing will be subtracted, and that's our answer. Let's see, yeah, okay. Now let's look at the answer in the book. Now the answer in the book wants you to break this thing up. What is that? That's log of 3 times 5. I mean log 3 plus log 5, okay? So that log 3 plus log 5, that's taken care of. I won't write that out now because that's just remember you break this, that's log 3 and log 5. Then let's check the answer, okay? There's x, okay? X minus 1, and then minus log 3x plus 4, and then minus again, because there's a minus sign outside parentheses, so when we take it out, this is also minus 2 minus 6. Yep, we're done. Okay, so that's example 2. And you might wonder, why are we doing this? It's just a demonstration to show you that how log works. So now you do a whole pile of it at the same time. But for the most part, it's just a matter of writing a bunch of stuff. So that's that. Next, let's do the power rule after I erased all these things. So next, let's talk about the power rule on page 609. We have, is it 609? Why am I on 609? Yeah, it's right. Towards the bottom. The point is, well, I'm going to make up a slightly different example than the book shows, but it's the same principle. Let's say we're calculating log of some base, right, of a number m, and it's being raised but m is being raised to the power 4. Again, bm by definition, we'll call it equal to c. That means b to the power c equals to m. Okay, that's the principle. Now, having said that, then that's what is that? Then we can, this is the same as m multiplied by itself 4 times, right? So this is equal to log, if we apply b, m times m times m times m, right? There's 4 of them being multiplied together. And so by principle then, that by this principle, that means we have 4 of these things being added together. So by the product rule of logarithm, where multiplication translates into division, that is going to be equal to m plus, do this again, okay? The first one and the second one and the third one, you just, and the fourth one, plus log bm. In other words, however many you have in the power, right? That's how many you got, and then you have to individually add it up, which means that this basically equals to, you can put the 4 in front. That is, this equal to 4 log b of m, right? So, and that is true in general. If you imagine any product here, okay, raises some power, and then the power can just imagine there's that many of them all being added up, right? And you might as well just put that number in front. It's 4 times that many. And so that explains the power rule, which is log of, let's say we have log of c, any base, okay, to the power, say, m, let's say, that is the same as pulling the m in front. This is the same as, okay, m log c. So any power becomes multiplication. Okay, and so that's the third rule of of logarithm. Let's see. Okay, so that is having said that, let's look at example 3 on the page 610. All right, example 3. I'm not going to write it down because I just told you the principle. Anytime you have log to the something to the power of something, all you have to do is kick that thing to the front. That's it. Kick it right over here. So right now we have log base 2 x to the power 5. Kick the 5 to the front. That's the answer, as you can see here in example 3. That's it. That's the end of that's the end. Okay, and then you can also do it the other way, I think. Let's see, what are we doing here? So well, and never mind the other way. Okay, now, right now we're just doing something like this. So let's look at example 4. Okay, example 4 on page 610 says we need to calculate or simplify or something this thing. Now what is that? Well, 25 is the same as log, let's see, I need to hold this thing at the right angle. Log 5 squared, okay? And you just kick the 2 in front, and that's your answer. See, it says so right here in the book. Okay, kick the power in front, and that is that. And then that's example 4. And then the next thing is let's see. Let me see if I should talk about this. Now, please look at the top of this page, 610, that I want to mention this thing right here. Now, the power, so far I've given you the power is a positive integer, right? And now at the top of the page, as the book mentions, it doesn't matter if the power is a positive integer. It might be a fraction, it might be negative, none of that different. It changes anything, okay? This rule applies no matter what m is. If m is a fraction or an or negative number, you kick it, the negative number with its negative sign all the way down here. If it's a fraction, you move the whole fraction here. If it's a negative fraction, you move that whole thing over here, okay? Whatever is up here can be kicked right over all the time, always. So so that's that. Now, having said that, let's do what's next. Let me see. Now, I want to do the problem that's in the try section, right under example 4. On the 610, I think. So let's do this. Okay, what is natural log 1 over x squared? To do this, remember, what's on the things that are on the bottom is the same as a negative exponent. That is, this is the same as natural log of x to the power minus 2. Okay, and then you kick the 2 in negative 2 with a sign and everything in front, and this is equal to minus 2 natural log of x. That's the answer. Okay, so whatever's up there, we'll kick it to the front and call it done. So that is that's that. So next, let's look at example 5 on the following page. Now the question is, what if I start here and I want to go here? Okay, that is, if there's a number, example 5 says we have 4 times natural log of x. What if I wanted to go backwards? Well, if you go backwards, then you do this. Whatever is in front, you kick it up onto the top. That is 4 natural log of x. Okay, that is the question on this right here. Okay, that is natural log x to the power 4th, which is, let's see, on the other side. You see, that is the answer. So if you want to kick it the other way, that's fine too. Kick this thing up, down, whichever way you want it. So that is, that's example 5. So next, let's do example 6. After I erase the board. So here is example 6. On page 611, we need to break this thing up into a bunch of addition, whatever. Okay, so that would be equal to, first we'll break it into addition and subtraction. The logarithm multiplied becomes addition, division becomes subtraction. Okay, so let's do that. That would be natural log of x to the power 4th. That's the first thing. That's multiplication becomes addition, so natural log of y, okay, and then the 7 is on the bottom of the division line, so subtract natural log of 7. And so that part is done, but there's a fourth power, and then we apply the power rule. Any power will be kicked in front, okay? So just this part is equal to 4 log x. So that is the answer. Okay? Let's check to see. Why do I say log? I mean natural log. Let me fix that. So I fixed that. So this is just 4 natural log of x, right? Plus natural log y minus natural log of 7. That is the answer for example 6. So let's go to the next page, example 7. Okay, so example 7, I'm just going to talk about it. We have a log of square root of x. What's square root of x? Square root of x is the same as x to the power 1/2. Okay, please review chapter 1 exponents if you are unfamiliar with this part. Now, having said that, if x is to the power 1/2, doesn't matter what's up there. If it's 1/2, kick it to the front. All right, so then we have the answer is that you kick the 1/2 to the front. That is the answer. 1/2 log x is the answer to example 7. Next, let's see something. Let's do example 8. So I have example 8 on page 612 written down here. Well, we will simply do what we did before. Okay, just multiplication becomes addition, division becomes subtraction, and the power gets kicked to the front. All right, so knowing that, then this will be equal to one thing at a time. First, we'll deal with 64. So that will be log 6. What's 64? 64 is 2 to the power, it's 8 times 8. So it's 2 to the power 3 times 2 to the power 3. So it should be 2 to the power 6. And we'll kick it over later. Okay, then plus log of x cubed, we'll just kick the 3 over now. Okay, this is log 6x, because all powers get kicked over. And then this is just that, plus log 6 of 4x plus 1 plus 1. Where's my x? I'm missing the x. 4x plus 1. Plus 1. All right, and then this was on the bottom becomes division becomes subtraction. It says right here. Okay, so then minus, I'll write it over here, I guess, maybe over here. Okay, minus log, keep going, log base 6 of 2x minus 1. All right, and then and that's it, and we'll kick the 6 in front. All right, right. And we'll do that by getting rid of it and putting it over here. That way we don't have to write this whole thing again. All right, so that should be the answer. Let's check to see if I missed anything. What is the answer? The answer is 6. Okay, 6 log of 2, 3 log x, log 4x plus 1 minus log 2x minus 1. That's it. See? As a logarithm is very easy to do, okay, most of the time. Even if it looks long, it's not a big deal. So it's anyway, so that's that. And let's so having done that, let's do the next thing. Example 9 on the next page. All right, let me write that down. So here is example 9 on page 613. We're supposed to condense this. We've been expanding, okay? We'll blow this thing up into a chain of stuff. Now we want to put them together again. That is, do the reverse process and turn it into something like that. Now notice that the base is all the same, okay? And that's extremely important. If the base are not the same, then you can't, none of this works if the base is not the same. So all these logs, it better all have the same base. Well, that one doesn't, well, yeah. So the basis has to be the same for any of this stuff to work, okay? So having said that, let's do this. Then remember, addition translates back into multiplication. So we're working backwards, but so this is log base of 3. And then addition translates back into multiplication. So 5 times 8, that's a multiplication dot. And then the subtraction translates back into division, divide by 2. And so that would be equal to 5 times 4 log of 20, which is correct, as you see in the book. So that's problem 9. Next, let's look at example 10. Actually, I decided that we'll continue with example 10 in the next video. So for this video, please, this is a part A of the two parts. So for this video, please do problems on homework section on page 616. And of course, please do the examples 1 to 9 that I covered in this video. Redo them yourself, okay? That would make sure that, then you should make sure that you know how to do the homework. So for homework on page 616, please do problem 6, 7, 11, 13, 17, 19, 21, 23, and 31. And when you're done, I want to talk about some of them. Okay, now that you're done with the homework, let's talk about, I want to talk about problem 6. The problem 6 has 2 fraction lines. Now, whenever students see 2 fraction lines, they tend to feel confused, like, what am I doing here? What happens is that you remember focus on the longest fraction line, okay? And because what that means is whatever's on top right here, okay, is being divided by whatever's on the bottom. So you focus that way. So then, so this is one object. We'll put it in parentheses to see it that way. We'll ignore this fraction for a second, okay? And just apply, well, this is a clump of something and it's being divided by what's on the bottom. That's how you look at it. So then apply the subtraction rule, right? Division translates into subtraction in logarithm. So let's write that down. This will be equal to, by the quotient rule, then we have, this is the same as log 4 of what's on top, which we'll write it down as x over z, and then minus what's on the bottom, okay? Then this log 4 of w. Okay, so that part is done. And next, then now you can focus on this. This is the same as is a simple subtraction, division that translates into a simple subtraction. So that will be equal to log 4x, okay, subtracted by log 4 of z, and that's just this part. And then the entire answer, then you add that to it, minus log 4w, so the whole thing would be the answer to this problem. And that's problem 6. Next, let's look at problem 13. So problem 13, we have minus log b 1 over 7. Now, anything that's on the denominator is the same as to the power negative 1. That's a rule from chapter 1, okay? So we will write this as, we'll write it over here, actually. We'll write it, this is negative log base b of 7 to the power minus 1, okay? And because 7 is normally to the power 1, and if it's in the denominator and you raise it on top, you have to change it to a negative sign. And so then kick this negative sign up here. The negative sign is the same as minus 1. Okay, we'll apply this rule with m equals to minus 1. So this is the same as the log of base b, 7 to the power minus 1 times the minus 1 over here. So which becomes plus 1. Okay, this is being multiplied. So the answer is log base b of 7. And I checked the answer, and it is correct. So far so good. Next, let's look at problem 17. Okay, so here's problem 17, which I have written down here. The first thing we do is get rid of the radical sign by translating it into the exponent. So that is the same as, let's see, the radical sign is the same as log of well, right now we're not doing any logarithm. We're just turning this into something that's more palatable. So that is the same thing as the whole thing to the power 1/2, okay? So each one will be divided by 2, each power. So x, it becomes 3/2, okay? Because this will apply here to become 3/2. And the square root applied here will become y equal to the power minus 2. All right. So that is again from chapter 1. Please you must know how to get from here to here. okay, without regarding to the logarithm, and review chapter 1 if necessary. So anyway, so when we got that, then we split it up, and multiplication becomes addition, right? And we will kick the power to the front. Okay, so we'll do both at the same time. That would become, so this part becomes 3/2, and then log of x. That's plus, being that this is being multiplied, and then kick this thing in front, minus 2 log of y. And that should be the answer. Let me check. 3/2 log of x minus 2 log of y is right. Okay, so that's the answer at the back of the book. So problem 19, I have written out here, we have a pile of stuff. The first thing we need to do before we do any logarithm is let's clean this up, okay, with the exponential rules that we learned in chapter 1. So let's do that. That would be equal to log of x to the power, what is that? That's 2, okay, and then plus, this is 2/3. And then y to the power of 3 plus, this thing is 3/5, okay? And that is, that's the way it is. And then, and so once we've done that, then that should be it. So then we have, generally speaking, we have 2 plus 2/3. Let me check the answer, which is, yeah, well, they want us to be turn this thing into a fraction. What's 2 plus 2/3 into a fraction? That's 6/3 plus 2, that's 8/3. Okay, so we have 8/3 log of x, because once the power is 8/3, you kick it to the front, okay, by this principle right here. Kick the power to the front, so that's that part, okay, and then plus, because this is multiplication, translates into addition by this principle here. So plus log of, I don't have any space for writing the number. First, let's figure out what the number is. The number here, which is kick the exponent to the front, right? And that's, if we turn this into a fraction, that's 15 plus 3, that's 18/5. That's the exponent, 18/5. And then the y to the power, sorry, where's my log? Let's write, so we'll kick the power to the front, log y. Okay, so the power gets kicked to the front, okay, the power that happened to be 18/5, I believe, and then log y, and these two things are being added because they were multiplied before. So that should be right, and this is problem 19. Let me check the answer. 19. The book says that, oh, sorry, I wrote this fraction wrong. The book says that I got it wrong, which I did because it's 5/3, for heaven's sakes, right? Y is to the power 5, and then the cubic root, which is the third. Okay, so that changes things a bit. That's, so what's 3? 3 times 3 is 9. 9 plus 5 is 14, so that should be 14/3. Is that right? Yep, it is correct. Okay, 14/3. Okay, so now we got the right answer, and that is problem 19. Next, let's consider problem 23. We have, well, now we need to, now this is already broken up and we need to pack it back in. All right, so we will reverse the rule. Okay, this equal to that sort of thing. Now let's, so that equals to, first we'll write down the logarithm, equal to log, and then x will be here, okay? The minus means division. Subtraction is division when you go back. And so that will be, and then we'll kick the 1/2 back up onto y. So it's y to the power 1/2, and y goes on the bottom of the division line because there's a minus sign. Put the 1/2 up. Okay, that should be good. And then this is a plus, so it's multiplication. And z, we'll kick the 3 on top of the z. So z to the power 3, and that should do it. Let's see, what is that? X is c cubed divided by square root y. Yep, we are done. The answer says that it put a square root here, which is fine. Okay, either one is acceptable. One's as good as another. And that marks the end of this section. And in the next section, we'll continue this is part A. In part B, in the next video, we will continue this section.